Now I'm gonna show you how great this Seaborn library is when it comes to visualization. It can easily show you the relationships between multiple parameters. Let me show you. If I am right now to show you the relationship between the bill length and the bill depth, okay, with respect to every species, we can do that very simply using one line of code. Take a look. If I say SNS dot implot, then let's pass the x is actually my bill length. I'm gonna copy it as it is. And my y is actually my bill depth. All right? It's like the mouth of this penguin or the bill. Then we need to specify the data. The data is actually the data set we have, which is this variable. Then with respect to what would I like to show the bill depth and length? Is it with respect to the sex, or is it with respect maybe to the island or to the species? Let's make it with respect to the species. So here I'm going to say hue is equal to species. Of course, species is a string, so this is species. Next, I can specify markers. So I'm going to say here markers is equal to X, O, and V. This is how should every category look like. Because I have 3 species, I am giving every species a special look. Alright? Now, if I run this, okay, this is lm plot. Alright, take a look what happens here. As we can see, the data is looking like that. Look, the X's are for the elderly species. And here we can see the relationship between the length and the depth. And we see that for elderly at least, the relationship is not actually linear. As you can see, the data is scattered way too much around this line. This line is trying to approximate how the data looks like, but it's not really doing a good job. Now, take a look at the chin strap. This chin strap is a little bit more linear when it comes to the relationship between bill length and bill depth. Yes, there is some outliers, but it is way less outliers than, let's say, the Adili. Same thing for the Gento. The Gento as well is still kind of linear relationship when it comes to the relationship between length and depth. Now, see how we did that really quickly and really simply? All we needed to do is just specify what is the relationship I'm looking for, which is in my case the bill depth and the bill length, and then I divided it into per species by just passing here the hue equaling a species. Now, how about we separate these into 3 plots? I'm gonna copy all of this as it is, and I'm gonna be adding one more parameter which is called column. Now the column here is going to be species. So I'm going to be creating 3 plots for every species. Each one is depicting the relationship between length and depth. Okay, sorry, this one needs to be down here. Now let's run it. And here you go. Now you have each in a separate plot. Now how about we plot them according to sex? So here, instead of species, I would like to see if there is any relationship with respect to sex. Now, sex, we have only male and female, so we need only X and O. And here we go. We can see that we have separated the data to the penguin, be it a male or a female. Now, let's remove this column. Now, when we plot them together like that, you'll see that there is 2 clusters. You'll see that there is kind of 2 clusters. Now, when you depict them like that, you'll see that, well, there is a little bit of separation between the bill for the male and female, but it's not really that big of a separation. Yes, there is some extremes here, we have some extremes here, but the overlapping is actually a lot. Now, how about we depict the flipper? Okay, so let's say we want the relationship between the flipper length and the flipper width. So this is my flipper length, and here is my flipper width. Now, let's try to see if there is a relationship between body mass and maybe the length of the flipper. Okay, Let's see if this is possible. So we need the flipper and the body mass. And let's say this is about species. And here we need to add one more symbol. So let's say W. Let's say V. W is not recognized. Maybe the V is. Okay, so V is recognized. Well, this is interesting. As you can see, the Gento is a little bit separated with respect to body mass versus the flipper length as a cluster. But for the chin strap and the Adelie, we will see that they are clustered above each other. So this is regarding clustering. Now let's try to plot them next to each other. So I'm going to copy this and just change the name to column to plot them all separately. Well, the relationship here is not really that linear, but at least we can see that it is not linear. What I would like you to do right now is to play around with this data and see what kind of relationship you can extract from it.